Hi guys, we're back. Today we have a video for you about series and parallel circuits and knowing the difference between the two. I am Miss Agar.
I'm Mr. Bremberger.
And here we go. So first we're going to just take a look at series circuits, and that word series should be something that you've heard about before. I have down here one of my favorite book series from when I was younger, Series of Unfortunate Events. And you can think about series circuits just like you would a book series. So if we look up at the top here, we have only one path for the current to take in a series circuit. Kind of like if you were going to start reading these books, you would start at the beginning and just follow through in one path from the beginning to the end. In a series circuit, one other thing to know is that if we're using light bulbs, like in this example here, and like you've been doing in the first part of this unit, if one of the light bulbs goes out in a series circuit, all the rest of the light bulbs are going to go out. Do you ever have that happen to you at Christmas time?
Yeah, definitely. Used to drive me crazy. My mom would say, "Hey, Brian, take these lights and fix them." There's 1,000 lights on a string. One bulb would be responsible for wiping out the entire string of lights.
Disaster. So very similar to the book series, if you were missing, let's say you read books 1 through 4, and you're missing book 5, you probably wouldn't continue just reading them with book 6. You would have to wait, and you'd be done just like the series circuit.
Just like when I'm watching, some of those different TV shows I like, Breaking Bad, science show. You can't go on to the next season until you've seen the season prior.
Yes.
It's a series.
All right, so as we talked about in the last video, when you have a circuit like this, if you are adding resistance, you're increasing the resistance. Here we're showing 3 different resistors. You could think of each of these as light bulbs on one circuit. That current going through is going to decrease. Pretty straightforward. Now we're going to take a look at parallel circuits. Just a couple ways to think about parallel. Probably heard this word in math before, right? Parallel lines. Also parallel bars, right? Gymnastics. So in a parallel circuit, there are several paths for a current to take. If you take a look at this diagram here, we have our power source, and the circuit can go in all directions to these different resistors. In these circuits, if one light goes out, the current can just take a different path. So fortunately for us, with our Christmas lights, now we don't have to worry so much about if just one bulb burns out, figuring out which one bulb that is to try to get the whole strand to work. The trickiest part, I think, about parallel circuits is thinking about the resistance. So the resistance is going to decrease because the current has more paths to take. We still have 3 resistors, 3 light bulbs here, but the current has more paths to get there, so the resistance is decreasing. I have an analogy for you that will try to hopefully clear this up. It's probably a sight that looks fairly familiar. I see it out here in the hall every single day, in between passing time, kids trying to get up and down the stairs to get to class.
I think they need a fit video about how to act appropriately in the hallways. Pretty congested.
So my question here is, if this is what's happening in the hall, if we added another staircase or another path, maybe like right down here, what would happen to the resistance? Would the resistance of kids trying to get through here increase or decrease? Going to decrease, right? If we have more paths for the people to get through, there's going to be less resistance, less pushing, shoving, and you're going to get to where you need to go a lot easier. So resistance will decrease, and the current, like the flow of people in this example, or the flow of electrons in our circuits, is going to be able to increase as that resistance decreases. All right, we have just a couple examples for you. So 2 different circuits here. Mr. B, you know what kind of circuit this is?
Why don't you think about this for a second while I think about it as well? Maybe a pause or something. So I definitely think that one is a series circuit. because you have them all lined up in a row. If one goes out, the rest are gonna go out. So, yeah, I'm going series circuit.
Excellent. Definitely a series up here, which would mean
That must be a parallel, right? They're all lined up in parallel fashion. It's a little bit more complicated than your series circuit, which is another way that it helps me remember the difference between the two. So, yes, definitely a parallel circuit.
Alright, so in this case, if I were to say that this light bulb burned out, what would happen to the rest of the circuit?
All the rest of them are going down, for sure.
And in this case, what if I said that this light bulb burned out?
Only that light bulb that you have your hand on right there is the one that's going to go down. The other ones are going to stay lit.
Perfect. Alright, are you ready for this?
I think so.
Alright, a little tricky. So take a minute right now, pause the video again. Think about what kind of circuit is this? Any thoughts, Mr. Hughes?
Well, I think I see some parallel going on up there with A and B, but it also looks like a series of C and D. So I'm going to say both.
It is. This is an example of a combination, as is this series and parallel combination circuit. And different things could happen in different parts. So for this example, let's pretend that light bulb B here burns out. What might happen?
Okay. From what I know about series circuits, I think I can see a pathway for those electrons to travel through AC and D, so I think they're AC and D are going to stay lit up.
Absolutely. However, what if we would have both A and B burn out?
See, I think if that happens, we're going to wipe out the pathway for those electrons to travel, so C and D are not going to be lit up here in this case. All right?
Yes, absolutely. Awesome. So if you now kind of understand the difference between series and parallel, you can see that this is a combination of the two. If you figured out, just like Mr. B did, the difference between which light bulbs are going to stay lit or burn out, that is awesome. If you have questions about this, great idea to write down one of those as your question in your unit guide. And if you have other questions, be sure to see us as well.
All right. See you later.